This conference will now be recorded.
Okay, so good morning all and welcome back to the session. This is Big Data Masters program. In previous session, we have discussed about compression, and compression is of two types, what we have seen in our previous session. That is like process oriented or speed optimized compression, where we are talking about how to optimize the speed. And second one is storage optimized, where we are thinking how to save the storage. So in big data world, minimizing the latency is our main focus, and we are having different compression rate which can be parked into these particular categories. So once we are talking about speed optimized compression rate, so what we have seen speed snappy and algedo. So these are the two techniques which are used in order to boost the performance, in order to minimize the latency. However, it is not going to save disk space if we compare it with gzip and bzip2 bzip gunzip and binary zip. Okay, but it is going to boost the performance of our application. So in order to have these particular compression rate, whatever you want, like if you want snappy, algedo, gzip or bzip, okay, whatever you want, what you need to do, there are two things. There are two things. Like first, uh, you can set the properties. We are having certain set of properties. So you can set these particular properties in Hive. Or second one is you can set the properties in our XML files or configuration files. So we are having two configuration files. Let me show you. So we are having MapReduce, mapred.xml or hives-site.xml. These are the files which where we need to set the properties in order to have the compression. So how, where we will be able to find these particular files? So you just need to go into the file system. Okay, you need to click onto the computer. Inside computer we are having file system, etc, and inside etc we are having Hadoop, which is having MapReduce, mapred-site.xml. So this is the first file where you need to set the property. Okay, and second one is inside the Hive. So over here, just have a look. We are having Hive, of a directory with the name Hive. You need to open it. Inside we are having conf, and inside conf we are having hive-site.xml. Okay, let me open this. So once you are going to open this, so previously in this particular file, we were not having these particular configuration. Okay, so this is the property in order to compress. I will share you. I will share one thread. Okay, with you all where these particular details are mentioned. So I have referred this particular thread over here. You are able to see. Okay, so what you need to do, you need to set the properties inside hive-site.xml, and inside. So with respect to hive -site.xml, we are having these particular properties. Just have a look. Okay, so hive-site.xml, inside this particular file, what we need to do, we need to set the properties in this particular way. So property name, Naresh, do you have any
Sorry, sir,
issue?
sir. Sorry, sir, sorry, sorry, sorry.
Okay, okay, fine. So we can have these particular properties inside hive-site.xml, And with respect to the map reduce map-read hyphen site.xml, we need to set these particular properties. Just have a look. So for map-read hyphen site.xml, we are having these particular properties. So we can set these particular properties, and then we will be able to achieve the compression. So say this is with respect to the snappy codec. Okay, however, like we can set these particular properties with terminal as well, like compression output true, map reduce, this is with respect to the map reduce. Okay, and these are with respect to the hive. Okay, so we can set in this particular way. So what I have done, I have copied these particular properties from this particular file, from this particular thread, and I have pasted it inside the hive-site.xml. So you will not be, if you are going to open this particular file with just right clicking on the file or with vi improved, you will not be able to add it. So what you need to do, you need to go into the terminal. Okay, on terminal you need to just have this particular path. Okay, and with the help of vi editor, vi, and you need to paste the path and hyphen site.xml. Okay, paste. And inside the Linux world, if you are like going to open it and you are going to add it, you will not be able to add it, because this is you need to have admin rights. So what you need to do, you need to mention sudo in front of this, and then you will be able to edit the content of this particular file. Okay, so just have a look over here. I have pasted all the configurations what you have seen over there. Okay, so this is with respect to say hive executor compress output. I just want to have the compressed output. Okay, so one property I have set. If you want to set the remaining properties, you just need to pick these particular properties from here. Just let me try to show you. So we are having these particular properties. Compressed output. Just a minute. Okay, so this particular property we have set. Okay, you just need to copy and paste it. So we are not having you can say other properties, we just need to copy and paste it over here. Let me try to copy and paste it over there. I just want to show you like how you will be able to do this. So over here you just need to copy this, and then you need to press the escape key and then I. Okay, is it vi editor? No, this is not vi editor. Okay, I. Okay, so once you are after escape, you are going to press the I, so it is going to take inputs from your side, and you just need to right click over here and paste it. So you will be able to paste these particular properties which you have copied from there. Okay, and let me press space. Okay, you need to maintain the symmetry. Okay, like how these particular properties are typed over here, and with the help of this, like you will be able to have these particular properties. Okay, and this one. Okay, so in this particular way you will be able to paste these particular properties or copy from there and paste it over here. Now in order to save this, what you need to do, mhm, just a minute. Colon Q. Colon Q, like quit without saving. Okay. Okay. So let me mention over here. How to edit the mapred hyphen site.xml and hive hyphen site.xml. Okay, so this is the stuff what I want to show you. Step like in order to edit, what you need to do: step 1, open the file with sudo vi is the editor, okay, vi is the editor, and then path of file, so it might be mapred hyphen site.xml or hive hyphen site.xml, so it might be any file. Open with this command, below command. Okay, once you are going to open, then in order to insert, escape and then plus I. Step 2, escape key plus I in order to insert the properties in the given file or open file. Step number 3. Okay, step number 3, what it will be, uh, paste the properties in the file. Step 4, what it will be, step 4 colon wq. Okay, colon wq in order to save and exit, and colon q in order to exit without saving. Okay, okay, so it might be possible like the editor is asking the exclamatory sign after the q or wq, so you just need to read the instructions and you need to proceed accordingly. You need to override the properties inside the configuration file. Now these are the 4 steps that you need to take in order to change the property of mapred-site.xml and hive-site.xml. Once you are going to set these particular properties, then like the things will work for you. Okay, and another, you can say, way in order to set these particular properties, what you can do, you can copy these particular properties. I have pasted all of these particular properties over here, and run and execute it, these properties, and set these properties via hive. Okay, you can refer any, you can say, mechanism. Okay, either you can proceed with the first step or you can proceed with the second step. Ultimately, like, you are going to set the configurations, and once you are going to set the configuration, then you will be able to get the compression. So I'm having a particular code, let me copy and paste it. So I'm having this particular code. This is the simple code in order to test. So I'm going to create a table that will be, say, compressed table, and let me mention, say, compressed table 6. Column 1 is of integer, column 2 of string, row format delimited, and fields terminated by comma. So, and let me remove this one. So it can work with this particular property as well. it can work with this particular command as well. So over here, like if you are going to set the ggzip codec, let me try to if I'm going to execute this, so on this particular table ggzip codec will be applied, and if I'm going to set the codec, different codec over here, say snappy, then that particular codec is applied. So you just need to set the codec over here in this particular property. Previously we are mentioning over here, however, like we can mention the codec over here as well. Okay, after setting it over here, like you can set all the properties over here, and then you can like define it over here, then also it will work, so we are having different, you can say, ways in order to have the execution. So we are having this Hive terminal. Just have a look and say use batch 32. Okay, I'm going to use this, and now I'm going to create the table. Okay, so table has been created. Show tables, and that is compressed 6. Customer compressed. Okay, compressed table 6. This is the compressed table what we have created. Now I want to insert certain records in this particular table. So I'm just insert into compressed table, and I'm going to enter certain records. Okay, so okay, so the execution will start. It will take like some time in order to insert the records, and you just need to pay attention over here. So I have inserted with the help of this. Now the like insert is like happening over here. Insert is nothing, where like there is no need of reducer. So reducer 0 and mapper 1 is working, and I'm able to get, I'm able to have the records in this particular table. Okay, so I just want to show you something. Now what we are having, describe, formatted, and compressed table 6. Okay, so this is the table, and on this particular path we are having this particular table, a compressed table 6. Let me copy this particular path, copy, and what we are having, compressed table 6. This one is the compressed table 6. So Hadoop fs-ls, and then we need to mention the path.
Table 6. Table 6.
6. Yeah. Okay, so just have a look over here. The snappy codec has been applied, right? Are you able to see?
Yes.
Yes, Ashok. We set the property for snappy codec, right? If we set
Yes,
all
yes.
the properties like
Yeah,
zip,
you can set.
snappy.
You can set and you can change it as well. So just have a look what I want to show you. Inside the configuration file. So inside the configuration file, mapred. So let me close this. Okay, so we are having Hadoop and mapred hyphen site.xml. Just have a look. So in this particular file, what I have set, just have a look. the snappy codec has been set, right? The snappy codec has been set, right?
Yes, but Ashok, what if we have like configured other
Yes,
codes as well, gzip
yes,
in
yes,
the
you
same
can
flow?
set, and then you can change the codec over here. Okay, you can change the codec over here. The table properties, I have
Okay, okay. That day.
the table properties,
Hmm.
and you just need to mention the codec, right?
Okay. Okay.
Right?
Got it.
Okay, and what we can do, let me try to move it in this particular way. Okay, and now what I need to do, one thing we have missed, so probably it will not work. Now I will tell you why it will not work. Hadoop fs-ls. Compress table 7. Okay, okay, now we are not able to see the extension, right? Right, ggp is not, we are not able to
Yes.
see ggp, okay. So
Yes.
what we need to do, we need to set the property, so we need to set these particular properties over here inside this. It is fine. Now we can have the execution of this particular command again, and now we will see. Okay, so the execution has been done. Let's validate it over here. Oh no, just a minute. It should not be like this. So we have set ggip codec. So extension should be the ggip. Okay, right? So
Yes,
over
clear.
here, this particular line is throwing error. Okay, table properties. I think the ggip we are not mentioning in the correct way. Okay, we need to identify like the probably it is ggip codec. Right, so probably it is having a different name over here, and that's why it is not picking this property. However, after setting this property ggip codec, it is able to provide me the outcome in the Ganji format only, right? So if you want to have the outcome in Snappy, then you just need to run this particular property. You can set it over here. So from this particular example, what we have done, we have set the property in hive from the hive terminal, and then we have created a table, and then we are able to see it is in Ganji format. Previously, what we have done, we have set the property inside the mapred-site.xml. Over here, only single codec has been defined, snappy codec. Okay, so probably like snappy codec and Ganjip codec will be the name that we need to put. You just need to validate. Probably why this particular line is not working, because of the codec. Might be it is in this particular format, Ganjip codec. We are using ggip, but it is not picking, so we need to identify the correct name. This line will work, definitely it will work, but we need to use the correct name, right? So you can check it. However, like we are able to get the compressed output, right? Is it clear with everyone?
Yes, Ashok, clear.
Yes, Ashok.
Perfect, perfect. Now one more thing I want to show you. You can validate it from the Hive itself. So over here we are checking it inside the HDFS. But we can run the command over here as well. And how we will be able to run? Say DFS, and you just need to mention the path. So DFS and ls, and this is the path. Okay, okay, just have a look. 7, we need to check it for 8. 8,
8 or 9?
8 or 9, 9, sorry.
9. Yes.
9, 9. Okay, okay, so it is coming in the Ganji format, right? You can check it once again, right? Fine. So we can validate it from the Hive itself, and it is coming in the Ganji format. So this was the challenge in our previous session, that we were not able to get the outcome in with the extension of the codec used, and we have validated it with the help of uh, Snappy and ggip. For the remaining one, lzo and the bgip, you just need to run it, and you need to validate the outcome. What I have mentioned, you can set the properties inside mapred and hive-site.xml, and after setting the property, you will be able to get the compressed output. Second way, like you can set the properties inside the terminal, and then also you will be able to get the compressed output. So depends on you how you will be moving, and let me save this particular. I will share this updated file with you all, and then you will be having the better clarity. Yeah. So this is about the compression. Moving further, you will be getting the, the updated file. PySpark. Okay, so friends, so far what we have seen, we have gone through with the big data basics, and then we have started Hadoop, then we have gone through with Hadoop and all. Let me write it down. Okay, we have started with big data basics. Okay, where we have seen like what is big data, why we need to have this particular term big data, then what are the different, you can say, properties if we are talking about big data: volume, velocity, variety. Okay, so different, you can say, properties are there once we are talking about big data. And what is the importance of big data? So once we are talking about data or big data, then there are two main aspects, like processing and storage. Processing, and second one is storage. There are two main challenges in order to handle data or huge amount of data: processing and storage. So processing and storage, and we have gone through with Hadoop. So Hadoop is the combination of different tools which are going to provide us a mechanism in order to store and process huge amount of data. So like we have gone through what is Hadoop and its component. Okay, so processing was taken care by SDFS. Hadoop distributed file system storage is taken care by SDFS, and processing is taken care by MapReduce. Okay, so the issue what was there with big data, like how to process and how to store, that was taken care in a good way with the help of Hadoop. And like we will be able to process huge amount of data. Okay, that was fine. From the Hadoop perspective, we have seen its component, its functionality, Hadoop commands and all. Hadoop commands. Then we have gone through in detail with MapReduce. Okay, MapReduce. Then we have started, like we had a small, you can say, flavor of from the scoop side. You have used scoop commands and all. Some commands you have used from the scoop side, like how to import and export the data. Okay, then we have started Hive, and from the Hive perspective, we have gone through with basic Hive, and then advanced Hive. Okay, and inside the advanced Hive, we talked about optimization, optimization related stuff. Basic Hive, like we had the understanding about how the Hive is functioning. So from Hive, we have seen these particular things. Then we have moved with file formats, and then compression. This is the the last topic, a compression. So what we are able to see in order to process the data, like we had a journey so far. So with respect to the journey, what we can say, like, we are having the raw data, and we are, say, ingesting it with the help of scoop, and then what we are having, we are putting it inside the HDFS. From HDFS, what we are having Hive, And on Hive we are using different techniques. It might be say file formats. We can have compression and all. Compression on top of this, what I can say, we are having partitioning, bucket, okay, and many more optimization techniques we have seen with respect to Hive, and these are utilized in order to process or have the analysis from huge amount of data. Okay, that is perfectly fine now. But what we have seen with the help of this particular journey, say if we are using Scoop, Scoop is having its own coding methodology. Hive is having its own coding methodology, and let me show you one diagram. Okay. Mm-hmm. Hmm. Let me show over here. Hadoop ecosystem. And let me open this one. This is from Geeks of Geeks. Okay, so what we are having, say we are having storage. From the storage perspective, what we are having HDFS. HBase that you are able to see over here, that is nothing but NoSQL database, which is used in order to query the data which is stored inside the HDFS. Okay, so HDFS is utilized and Yarn is utilized. That is, you can say a cluster manager over here, which is managing the resources. Now, what we are having MapReduce, that is nothing but the processing framework of Hadoop ecosystem, and Yarn, this is nothing but the cluster manager. Cluster manager. Over here, what you are able to see, we are having Hive, which is working onto SQL-like language. It is a SQL wrapper on top of Hadoop. Then we are having Pig, which is utilized for the data cleaning and all. We are having Mahot, which is utilized for machine learning applications, like how to apply the machine learning algorithms on the data which is stored inside the HDFS. So Mahot is a framework which is you can say developed by an IITN, okay, and it is able to apply a machine learning algorithm onto the data which is stored inside the HDFS. Avro, Avro, like we are having this Avro, that is over here, it is mentioned say RPC, okay, remote procedure call. But we have leveraged Avro as a file format. Okay, Avro is nothing a file format. Scoop is nothing but RDBMS connector, and it is utilized in order to have the import of data and export of data. And on top of this, what we are having for the data management, say we are having Uzi, which is utilized, which is working as a workflow manager. Okay, and like if you want to get the reports at 9 a.m. daily, so you can schedule these particular jobs with Uzi, that is a scheduler basically, and at 9 a.m. morning on daily basis you will be getting those particular reports. Chakwa, that is, you can say, monitoring tool. Flume can be utilized in order to have the ingestion of the live records if we are having streaming data. Okay, so we can insert it with Flume. And Zookeeper is nothing but the manager. It is utilized as a resource manager. So what we are able to see, we are having different tools, and all of these tools are responsible to provide or all of these particular tools are responsible to run a particular application, because in an applications we are having different phases. Like we need to ingest the data, we need to export the data, we need to apply certain machine learning algorithm and all, we need to have the analysis on top of that data, we need to perform the data cleaning and all, we need to maintain the resources and all. Okay, we need to have data security and governance practices. So a lot of things are there, and these are achieved, this is achieved with the help of different tools inside the Hadoop ecosystem. And all of these particular tools are having its own coding methodology. Okay, coding methodology means, say over here we are working with SQL. So inside the pig it is using pig Latin language, and then the code is written in the pig Latin language, which is utilized for the data cleaning and all. So different coding methodology means different language is what I can say. Different like if we are having one language says C and another language says Java. So both of these two languages are having different coding methodology. However, basics are the same, but like from the developer's perspective, it is very tough to learn each and everything. Okay, so at this moment, like if we need to perform 100 of the things with Hadoop, then we need to learn 100 of the programming methodology. Okay, what we are talking about, limitation of Hadoop, limitations of Hadoop. Okay, we have seen like with the help of Hadoop, definitely we are able to process and store huge amount of data, but there are certain limitations. There are certain limitations, and which are providing us the input in order to explore a new technology or new framework, and that like that is easy and provide you the least latency as well. So the researchers were looking with a particular solution. Now what I can say, like Hadoop was having different benefits, but there are certain limitations as well. First one is uh, if you need to perform 100 of the things, then you need to learn 100 of the programming methodology. What I meant to say over here, no uniform coding mechanism. Okay, no uniform coding mechanism. Each and every component which is utilized over here inside an applications, once we are using Hadoop, then each and every component is having its own coding methodology, its own coding style. So it is very tough from the developer's perspective. So you can think like if someone is working onto the terminal and using say Hadoop command and all, and if we are leveraging him to say write down the code in Java, so it will be very tough for him. It will take time, and uh, definitely like inside an applications we need to work on to the different aspects, and for different aspects we need to learn the different coding methodology. But uh, but researchers were not happy with this particular approach, and they were looking for a solution. Okay, second one is the Hadoop is disk processing system. Disk processing system. So what exactly is happening? Say if you want to process something inside the Hadoop, then once it is processed, then it is moved to the storage, and like if we need to perform the other operations onto top of that particular process data, then we need to read it from the disk and perform the operation once again. You can think in this particular way. You need to pay attention in order to understand the basics. Okay, so say we are having machine 1. Okay, machine 1 or node 1, node 2, okay, node 3, node 4. So in this particular way, like we are having multiple machines, node 1, node 2, node 3, node 4. Okay, so if we are going to process with the help of this particular cluster, this is nothing but the 4 node cluster what we are having, and we are going to process our data with the help of these particular node. So once we are talking about processing, okay, so what we are having memory and storage in each and every node. What we are having memory, okay, and then say storage is over here, okay, storage layer, what I can say, storage, okay. So in the same fashion, we are having node 2, node 3, node 4. Okay, memory of this node, memory of this node. Okay, memory, and memory. So if we are having an application, okay, that is say distributed among these particular nodes. Now, and we are having data that is stored inside the storage, and like once we need to process the data and process the data, then it will come inside the memory, and once like the processing is done, then the outcome is stored onto the disk, okay, as a result. And if like we need to perform the operation, then that particular result is being moved inside the memory, and say certain other data will come, and then operation will be done, and then the output is moved onto the storage or disk. In this particular way, like we are having multiple read and write operations, a lot of read and write operations are there. And once we are having read and write operation, then disk spinning is there, so disk spinning is nothing but like say that is involving physical movement of the disk, okay, physical spinning of the disk, that involves the physical rotation of the motor and all, and that is time consuming process once we are talking about the movement and all. So that is the time taking process, it might be possible like we once we are having the chaining process, say like the input is there like at the node 1, and it is going to move the data inside the memory in order to process. Once the process is done, then what it will do, it will move the result to the storage. The second node is going to read it, it will move it this particular data inside its storage, and from the storage it will go to the memory, then result will come inside the storage. From storage it will go to the storage of node 3, and then it will be moved onto the memory. From memory, after processing, it will be moved to the storage of this particular node. And once the next machine is going to work on this particular data, it is going to move this particular data inside its storage, and once from the storage it will be moved to memory, and then we will be able to get the final output over here, that will be written in this particular node. So chaining process, once we are going to have the chaining like process that will provide you the better visibility. So let me try to open the painter. Will I be able to copy it over here? Okay. Okay. So you can think in this particular way. Huh? Okay. Storage to memory, and memory to storage. From here to storage, and storage to memory, memory to storage. From here to here, storage to memory. After processing memory to storage, then here, then over here. After processing, it will be moved to storage. Okay, and that is a final output. Final output. Okay, so that is the case once we are leveraging the disk processing system. Like in order to perform the operation, in order to perform the processing of the data will be read from the storage only. And once I'm talking about the read and write operations, so for performing this, what we are having to we are having 8 operations. We are having 8 read and write. 8 read and write are there. Just neglect these 3 as well. Okay, or plus 3, then it will be 11 read write operations. Okay, so this is the case once we are having Hadoop. Okay, on the another hand, what we are having, what I can say, I'm having say Spark. Spark is in memory computation. So say over here, this particular memory is nothing but the shared memory. Okay, shared memory among all the resources. This is the shared memory. Okay, so what it will do, it will just read it once. Okay, all the processing will happen over here, and then it will write onto the outcome over here. Okay, so it means like previously once we are having 8 read and write, we are having just 2 read and write over here. Okay, so in this particular way, like the Spark is providing you the least latency. Okay, it is going to minimize the latency because it is in memory computation system. So as latency was there, high latency was there inside the Hadoop, so that was a limitation. Okay, so let me come on to the Hadoop. Okay, onto the limitation of Hadoop. This is the disk processing system, and once like disk processing system is there, so latency is very high over here. Very very high. Okay, okay, latency is very high. Another like challenge is say like it will not be able to work onto the small files. Okay, another a lot of challenges are there, but we can like stick on to these 3. Those are the major challenges. And at this moment, like researchers were looking for a solution that will be able to to minimize or to resolve these particular challenges. Then friends, Spark came into the picture. Spark came into the picture. Spark. Okay, so Spark is saying, say, it is saying, give me the give me the resource manager of your choice. Spark is saying, give me the resource manager of your choice, and give me the storage of your choice, and I will be able to perform the operations in a better way. Okay, so what exactly is happening over here once we are talking about Spark? So inside the Hadoop, what we have seen three main components: HDFS, and what we are having MapReduce, and what we are having Resource Manager. Resource Manager. Okay, storage, that is nothing but say storage, processing, and say resource management, or what I can say resource management. I can pick from here to here, and I can mention it as yarn. Okay, this is with respect to Hadoop, and this is the, you can say, functionality of these particular resources. Storage, HDFS is utilized as storage, MapReduce is utilized as a processing, Yarn is utilized as a resource manager. So Hadoop is saying, give me the storage of your choice. This is nothing but storage, and give me the resource manager of your choice, and I will be able to work in a better way. Okay, so what exactly is happening over here? Over here inside this particular you can see diagram, we are going to replace it with Spark, and then we will be able to resolve the challenges which have been faced over here. Okay, so Hadoop is not having the uniform mechanism, uniform way of coding, but Spark is going to provide you uniform way of coding. If you need to do 100 of the things, Spark is saying just learn one coding methodology and you will be able to perform all the 100 of the things. There is no need to learn 100 of the programming methodology. You just need to stick with one coding methodology, one programming uh, one way of programming, and then you will be able to solve all the 100 things. So Spark, Spark just learn one coding methodology and you can do all 100 of the things. Okay, so this is said by Spark. Second is, it is in memory computation, in memory compute engine. In memory compute engine. So previously what we have seen, once we were talking about the Hadoop, then a lot of read and write operations are there, and once we are talking about a lot of read and write operation, definitely disk spinning and all, okay, is there, and because of that the latency is very high. Okay, so inside the Spark, it is providing you less latency, so less latency compare to Hadoop, and it is 100 times faster than Hadoop. Hadoop, once processing is done in memory, okay, if you are processing on disk as well, and 10 times once processing is done on disk. Okay, so over here with the help of Spark, what we are able to get, we are able to get least latency, and there is no need to learn 100 of the things to solve 100 of the issues. So because of this, the Spark came into the picture. We were having certain limitations. We talked about the limitations inside the Hadoop, and in order to to solve the issues which we have faced inside the Hadoop, the Spark came into the picture. So Spark is providing least latency, and if we are talking about big data, then a tool is there which is able to minimize the latency. We definitely going to prefer that particular tool, and Spark is that one. So Spark is what? Spark is lightning fast, general purpose, in memory, compute engine. So lightning fast because it is faster than Hadoop. General purpose, what does it mean? It means for 100 of the things, okay, we just need to learn one programming methodology that is given by Spark, and we will be able to solve 100 of the things. So which was a challenge once we were talking about Hadoop, or once we were working with Hadoop, we were having different coding methodology. Okay, we have seen like for Scoop, we have having different coding methodology. If we need to perform the data cleaning, let me write it down. Okay, data cleaning, we are having Pig, and Pig is using Pig Latin language. Okay, we are having machine learning. So we are having Mahout. Okay, for data analysis, we are having Hive and Impala. Okay, for you can say streaming data ingestion, we are having Flume. For structured data, what we are having Scoop. Okay, for workflow, we are having Uzi. Okay, so we are having different tools, friends, and for different tools we are having different coding methodology. Okay, say over here the Hive and Impala, that is using SQL like stuff. Okay, SQL language, this is using its own coding methodology. Uzi is using its own coding methodology. So we are having different coding methodology once we were talking about Hadoop. So Spark is itself a general purpose, like there is no different languages in order to perform the different tasks. Okay, so with the help of one coding methodology, we will be able to perform all of these particular operations. Lightning fast, it is providing the outcome with low latency, and it is 100 times faster if we are comparing with Hadoop. In memory, so inside the Spark, the computations are being happening inside the memory. Whatever the data that you need to process, that will come inside the memory, and it will be processed over there, and then the outcome will be shared. Okay, so every computation, all the computation will be happening inside the memory only. Compute engine, why we are saying it as compute engine? Because we can have the storage, we can have any storage, and we can have any resource manager. So Spark is not limited to say HDFS and YARN. So we can have S3 as a storage. Okay, S3 we can have you can say RDBMS, we can have SQL, NoSQL, DB. Okay, we can have on premises data. Okay, we can have data anywhere, and it is able to read the data from that location, and then with the help of Spark engine we will be able to process. And resource manager is not limited to YARN, we can have Kubernetes, Mesos, okay, Spark standalone. Okay, we can have different, you can say, resource manager, right? It will depends upon you. Okay, so Spark can have any storage and any resource manager. Okay, from these particular list, storage can be anything. Okay, we have seen like 4 resource manager from the Spark side: Kubernetes, Mesos, Spark standalone, and Yarn. Okay, Yarn is the famous one, Kubernetes is the second one, and Mesos is the least utilized. Spark standalone, that is utilized inside the on-premises cluster. Okay, so it is the compute engine only. So over here inside the Hadoop, if we are going to replace MapReduce with Spark, then definitely it will be the Spark cluster. Over here, what we are able to see, this is Hadoop, but we can replace it with the help of Spark, and then it will be the Spark cluster. Entire, you can say, ecosystem like Spark will be leveraged in order to process the data, and then we will be able to get the outcome. We will be able to leverage the benefit of distributed computing with the help of Spark, and we will be able to process the data inside the memory, and that is going to minimize the latency. So it will depends upon you. So what I can say over here, Spark is going to replace the MapReduce, but it is not going to replace Hadoop. Hadoop still remains there. Okay, it can replace MapReduce, but it is not going to replace Hadoop. Spark is Spark replaced, what I can say, MapReduce, but Hadoop we can't say that it has replaced Hadoop. Okay. Okay, so this is the outcome from this particular, you can say, theory, what we are able to see. Okay, so Spark is going to replace MapReduce, but Hadoop, it is not going to, it is not a replacement of Hadoop. Okay, with the help of Spark, we will be able to process the data with low latency. That is fine. Now the main thing is that Spark is going to provide 4 different APIs. That is Python, Scala, Java, and R. Spark is written in Scala. Spark is written in Scala. So whatever the advancement coming, that will come inside the Scala first, and then it is replicated to the other programming languages. That is fine. So over here, you just need to learn a programming language. It might be Python, Scala, Java, or R. Okay, and then you will be able to take the benefit of distributed computing in memory computation from the Spark, and you will be able to minimize the latency with the help of this. So you just need to learn Python, and what we are from this course perspective, we are going to use Python as a programming language. So Python plus Spark, that is nothing but PySpark. PySpark. Okay. So for this particular course module, we will be going to leverage PySpark, and Python is mandatory for that. And in tomorrow's sessions, we will be having an overview of Python, like what are the different things inside the Python, and then we will start like writing our code in PySpark. We will be going to leverage certain functions and all, loops, mechanism, and all. We just have a review, or we just need to go through quickly what are the different things in the Python programming language, and then we will be able to leverage Python inside the Spark. Now There are different programming languages, Scala, Java, and R as well, which a person can leverage in order to process the data and minimize the latency. But like the Python is the easy one, and that is having the most or you can say high penetrations in that the market, and a lot of organizations are preferring PySpark nowadays. So we can proceed for for Python, Python plus Spark, that is PySpark, and we will proceed with PySpark. Our course module will be based upon PySpark. So once someone is talking like we are having 4 programming languages, Python, Scala, Java, and R, then which one is better? Okay, which one is better? So it depends upon the use case. If our use case is to minimize the latency, so Java and Scala, both of these particular languages are running on JVM. Okay, so if these particular languages are running on JVM, then it will be, you can say, the code which is written, then it will be directly executed onto the JVM, and we will be able to get the outcome. So if our organization is working on to say streaming data, that is going to have least latency, then someone need to proceed with Scala or Java. Okay, because over here it is the code is directly able to run onto the JVM. But once we are going to write down the code in Python, then we need to have a process which will convert the code in a format so that it will be able to run onto the JVM. So another process is involved over here, or has been added once we are working with Python. So Python is going to add a little bit more latency, that is in milliseconds or microseconds, what I can say. But uh, if the use case is to minimize the latency a lot, or you are working onto the streaming data, then you can prefer to work with Scala or Java. Preferred Scala, okay, because Spark itself written in Scala, and the code will be directly executed. There will not be any issue. Okay, so what I have mentioned, which language you need to prefer, that will depends upon the industry use case, on which type of data, on which flavor of data the organization is working, and based upon that you need to choose a particular API, either it is PySpark, Scala, Java, or R. Same thing is, you can say, with R, that is also requiring a process which is going to to convert the code in such a way so that it will be able to run on JVM. So Python and R will have one more process that will enable the code which is written in Python on R, that will enable to run it on JVM. So like a process has been added over here, and over here it is directly able to run. So you can think in this particular way, say Java and Scala. Okay, this is the code, and we are having, say, JVM, and we will be able to get the output. But once we are having, say, Python or R, then process is there. Process will convert it, it enable this particular code conversion so that it will be able to run it will be able to run on JVM, then we will be able to get the final output. So this is the difference. Second is the use case. Okay, so if the use case is majorly towards the data science side, like you need to apply machine learning algorithm, okay, you need to perform the data analysis, then the preferred one is Python or R. These are the best suited language for data science related stuff. And if your priority is towards the data engineering stuff, okay, then Scala and Java, both of these two languages are the preferred one. Okay, preferred, like highly preference is of Scala than Java. But what we are having Python. This is very easy to understand. And first, like, we will be going to grab each and everything from the Python and what I can say, PySpark. And if we are having the command on one programming language, then it will be easy to move on to the second one. Okay, so at least we must have the good understanding about one programming language. Okay, if we know all the basics of one programming language, probably, like, from all of you, nobody is having direct exposure of a programming language. So better one is Python. Okay, and we guys try to be towards the data science domain, because we are having data engineering plus data science uh, combination. Okay, so preferred one is the Python. Or we are not going to prefer because it is dedicatedly used by the data scientist. So Python, data engineering plus data science, and Scala for majorly for Scala and Java majorly for the data engineering. So this is the difference. And why we have mentioned, like, say PySpark, because this is the combination of Python plus Spark. It is going to leverage Python API. Okay, and in tomorrow's sessions we will be having the discussion about Python, and then slowly we will be moving towards the journey with PySpark. Like, probably tomorrow we will try to write down a simple program in PySpark, and we will try to execute it onto the IDE. Okay, so that's it for this particular session. If you are not able to understand anything, like why we need to have Spark and all, what are the different APIs, okay, so you can ask. Anybody having any doubt? Mukesh, Pankaj, Vikas, Naresh, Rohit,
It's clear,
any
Ashok.
doubt, any confusion?
No, it's fine, Ashok. One thing means we may need to learn this Scala as well in future, right?
Come again?
We may need to learn the Scala as well in future, right?
uh Actually, what happen, what will happen, uh these particular things will be learned based upon the requirement. Okay, so nowadays we are having list requirement, or like small number of organizations are working onto the streaming data. Less number of organizations, that particular you can say category, of the organizations which are, you can say, working onto the live streams of the data, that is very less. Okay, and say live broadcasting is happening, say one match is going on, or Netflix streaming, or weather forecasting system, live airline monitoring system. So such type of use cases are there where we need to have list to list latency. And from the Spark side, so like, once we are working with the batch data, that is perfectly fine, we will be able to leverage Python. But we are having certain another, you can say, different mechanism which are dedicatedly developed for working onto the streaming data. Like, we are having Apache Flink. This is Apache Spark. We are having Apache Flink as well, which is dedicatedly dominated to work with the streaming data, and it is going to provide the least latency than Spark itself. So once it comes with the least latency, and the organization is working on to such type of data, okay, use cases, they like with respect to the streaming data only, then either like they are going to prefer Flink, okay, and if they are going to prefer, you can say Spark, and if they are having the batch data as well, then definitely you need to have uh, the Scala in your hand. But for a learner or for a beginner, okay, it will be a little bit typical to move directly onto the Scala. Okay, so first, like understanding the Scala itself is a big task, and then learning Spark or implementing it in the Spark way, that is the another thing. So you will be having two hurdles at a moment. Once you are having Spark in your hand, and you just need to draft in the programming Scala programming methodology, then definitely you will be able to divert over there. So two things are there: use case. Okay, if the organization use case is streaming data only, then they are going to prefer Flink. If they are having batch data as well, then they are going to prefer Spark with Scala, right? And we are having list number of organizations, major category or majorly like organizations are working onto the batch data only. Even like inside the telecom itself, like organizations, we are having live monitoring and all, but we we love to work onto the batch data. Okay, so maximum stuff or maximum processing is done in onto the batch data only, right? Least number of use cases are there where we need to prefer the monitoring and all. So that is done with the help of Spark streaming. Clear?
Fine, Ashik. Yeah, for batch data it means PySpark will be sufficient.
Yes. And
Fine.
we are having lots of organizations which are working onto the batch data.
Mhm.
Less number of organizations are working onto the streaming data. Okay, even like you uh, try to type these keywords, say Spark streaming and all, and try to check the openings onto the Naukri. So you will be getting less number of openings, and batch processing or Spark processing, you will be getting huge number of, you can say, openings over there. So each and everything, like if the market trend is towards streaming data processing, definitely at this point of time we must be talking about Scala, right? However, streaming processing can be done with Python as well. It is not say Python is not capable to process streaming data. It is able to process, but uh, the the latency which is added because of this additional process which is utilized in order to convert, it might be anything. So because of, at this moment, like we will be able to once we are going to leverage Scala, so we will be able to remove this particular phase. Okay, so that is the benefit of Scala. And the challenge with Scala, it is a little bit difficult to learn now. I'm not using tough keyword over here. It is typical to learn now. It is very easy to learn now. So from the learner's perspective, beginner perspective, Python is the best. However, like in our previous sessions, okay, in first, second, or I think up to 15 batch we have gone through with Scala. But at this moment, like Python is penetrating inside the market, and the organizations are looking for the engineers who are having PySpark in their hand. So we have modulated our course material to PySpark, right? Initially, we were working on Scala only.
Right. Fine,
I
Ashik.
think Pankaj has attended those sessions, right, Pankaj? Scala.
Yes, yes, but still I'm comfortable with Python only.
Python is very easy to understand. That's why.
Yes,
That's why.
yes.
For the beginners, Python is the best. Even inside the market as well, the higher penetration is of Python. It is mentioned, say, for the data engineering perspective, out of these three languages, I'm not talking about four. If one is having the knowledge of one programming language, say Python, so he is good. And if he is having the knowledge of two programming language, data engineering with two programming language, or a Spark with two programming language, he is better. And if someone is having all the programming language, say Java, Scala, and Python in his hand, then he is the master of data engineering now. Okay, he's the master, he's the champ. So slowly we will be able to achieve the master title. No need to worry. But from the beginner perspective, from the starting perspective, Python is best for you. Right? Fine.
Right, sir. Right. Yeah, fine.
Perfect. Perfect. And so see you tomorrow. And then we will be discussing some basics about Python and PySpark. And we will be having major focus onto the PySpark. So list stuff will be covered from the
So,
Python side.
hello.
Yes, because you are
Yeah,
saying
yeah.
something.
Yeah. I'm just asking one thing here. Like Python, we need to go in the deep or just understanding of.
No. There is no need to go in deep. Okay. Each and
Mhm.
everything what is required, I will be going to cover. No need to worry.
Okay.
Okay. And you will be getting certain quiz, certain assignments, and definitely you
Mhm.
need to be interactive during the session. Okay.
Okay.
So
Okay.
you will be getting each and everything. No need to worry from the course module perspective. Okay. So thanks. Take care.
Oh,
Have a good
thanks.
day.
Okay. Thank you, Ji. Same to you.
Thank you, sir.
Okay.
Thank you.